So hi everyone, today we are going to discuss about experiment 6, which is about CNC lathe machine G-coding. So you can see over here we have an exercise which is to develop a CNC program for this step turning process. So let's say for example, in general, like when we are talking about lathe operation, generally we mean like turning process. And the step turning means is nothing but just reducing the diameter of the workpiece in steps. So what do we have over here is we are having a workpiece. Let's say for example I have not specified the initial dimensions, so I'll just specify the initial dimensions with the initial dimension of, let's say for example, the diameter of the workpiece is 30 millimeter. The diameter is 30 millimeter and the length of the workpiece is, let's say for example, it is almost 100 millimeter. Okay, the length is 100 millimeters. So it's a workpiece with diameter of 30 millimeter and length of the workpiece is 100 mm. So when we insert this workpiece, let's consider this as an aluminum rod. Okay, let's consider it as an aluminum rod. So when we insert the workpiece into the chuck, let's say for example the working area or the working that is remaining, it's 50 millimeter of it has gone inside the chuck. 50 millimeter has gone inside the chuck and the remaining is 50 millimeter. Okay, so you have 50 millimeter area or length of the workpiece to work on. Okay, so this is, so like I told you, our dimensions are 30 millimeter diameter and the length of the workpiece is 100 mm, in which you have 50 mm to work on. Okay, because the other 50 is inside the chuck. So now we need to generate the G code for this program or for this experiment. So one important thing which I mentioned during our lecture about G-code in general itself, okay, an important thing is in milling or lathe operation you will be going step by step in reduction. So you can see currently the workpiece is 30 mm in diameter. You cannot go and make suddenly 20 mm. No, this will destroy the workpiece as well as the cutting tool. Okay, this will destroy the workpiece as well as the cutting tool. So what you will do, you will go step by step. You will reduce or you will perform your reduction in diameter in step by step with a reduction of 2 mm. So initially it's 30, right? You will make it 2 mm, 28, 26, then 24, then 22, 20, and then you stop. So that part is done. So initially, let's say for example, you will give, this is your Z axis and this is your X axis. So diameter is X. Okay, over here the diameter is the X axis and this is your Z axis. So let me illustrate it for you. This is your Z and this is your X. So it's XZ axis. We know that because lathe is a 2-dimensional machine, whereas milling is a 3-dimensional machine. So here we have XZ axis. So let's say for example X is perpendicular to Z. Okay, so let's start with the G code. So what we will do, step 1 will be what? To write the line number, which is N1 G21. What does G21 mean? G21 means metric unit, right? We learned about this. So we are going to do our operation in metric unit. G21 means it's metric unit, and you know G20 means input is in inches. So over here we have chosen G21. So our measuring unit is in metric system. Now what I'm going to do, I'm going to write line number 2 and 2 M06. What is M06? It's calling the tool, right, or automatic tool change. So I said M06 T01. Okay, so I have selected my tool for this operation as tool 1. Okay, so you just, let's say for example in the assignment I'll be given with a set of tools, so you can just choose the tool accordingly. Okay, so for our operation we have selected tool 1 as the tool that will be performing the operation, tool 1. Okay, and then what is the next step? I need to specify my coordinates. Sorry, I mean, yeah, coordinates in the sense means to specify the origin. I already specified my coordinate, which is the metric system, and now I need to specify my origin. Okay, from where I need to start. So I will write N3. Okay, G00. This is specifying the origin. G00. Like I told you, what G00 is rapid positioning, right? And typically, like I told you, G01 and G00 are same, but G01 is like the word says, it's rapid, it's quick, so it will bring the tool quickly to that position. So if your tool is very far away from the workpiece and you wanted to bring it to the position quickly, always specifying the origin G00 is better. This is what we have understood. I have understood from from couple of many examples and these things, operations as well. So we will specify G00 X32 X32 Z2, and I will also specify my feed rate F3. Okay, the feed rate speed as 3 mm per minute. So right now I have specified my origin. This one you can also specify later. Okay, the feed rate can also be specified later, but since I put it in the same code, I just put specified over the feed rate over here. But again, if you start your first operation, you need to specify it again. Then only, or else it will generate an error or the code will not operate. But it's better to keep here, and then you can specify one more time. Doesn't matter. So in this line 3, what I have done rapid positioning, means specify, and I have set X32. You can see that the diameter is what, 30. So you can see X is a bit higher than the workpiece, right? This we have to do it. Always we need to specify a bit higher. Why is that? To avoid dragging or collisions later, right? So you can see I have specified X32. Even the Z is 2. Okay, so if, let's say for example, this is our origin. This is our origin. Okay, and let's say for example, when I'm saying X32, it's going somewhere above the workpiece. Okay, and I also said Z2, so it's away from the, so this is my 00, it's away, it's somewhere here, Z2, and I have specified the feed rate. Okay, now what is my step 4? I will say N4. What I have to do, line number 4, what I'm going to do, I'm going to call the spindle, right? And I'm going to specify an RPM for the spindle. So let me say this is clock M03 is what? I specify M03 because most of the time for lathe and milling operation we do spindle forward, not spindle reverse. Most of the time we do it spindle forward and the clockwise motion. Okay, this you have also seen when we were doing conventional lathe machine. Okay, M03, and I will also specify my spindle speed as 300. Okay, so by this, what you have done, you have specified what the spindle, you have called the spindle to operate, and you have specified the spindle speed. Okay, now what you have to do, you have to also specify the coolant. Means we are dealing with our workpiece is aluminum, like I told you. Okay, since our workpiece is aluminum or a metal, we will also call the coolant with the code M06 M08. We'll also call it as M08. Okay, so now you can see we initially specified the metric unit, then we specified the tool, we called the tool change, then we specified our origin positioning, we then called the spindle to work on, and we have specified the coolant. So this will be your first step. So by this, you are right now ready to operate your operation. You are right now ready to do your or perform your operation. Okay. So now let's start with our thing. I'll write line number 6, which is N6 G01 linear positioning, because we are doing linear operation over here. X28, you see I made it to 28. Okay, X28, and I will also, again, like I told you, for the first time you need to specify again the feed, right, or else it will generate an error. Even though you specified over here, it's also better to specify one more time, just in the beginning. Okay, so right now it is X28. Okay, so right now when from 32 it became 28, the tool became 28, and the feed rate is specified. Now what we have to do, we have to go in the z-axis, right? So that will be always x-axis and the z-axis specify in 2 lines, don't specify even one. Okay, this way it will reduce the error that can happen as well as the damage that can occur. So like I told you, this is something very important you have to keep in mind. Always do your x operation separate, z operation separate. So N7, once you have reduced the diameter, now you have to go in the z, right? You have to do a cutting operation in the z. So N7 G01 G01 z, till what you have to go, 10 10 10, z minus 30. Okay, so right now what we have done is we went from 30 to 28, we specified the feed rate, then we went along the z-axis. Now what you have to do, you have to come back. Like I told you in the conventional, if you come back, what you're doing, you're because the tool is right now with the workpiece itself, right? So when you're coming back, what you have to do, again move away from the workpiece, right? So what you will do for that, you will write, see, you will write what, N8 G01 N8 G01 X32 and Z2. So with this, what the machine understood, go back to the origin from where we started, go back to the origin. Now we will say N9, again we need to reduce it. So we went till 20, the last diameter reduction was 28, right? Now we will go 2 more, so it will become what, X01 G01, sorry, X26. Then you will specify your z-axis and 10 G01 Z minus 30. Okay, and then what you will do, go till 30, again the same thing repeats, N11 G01 X32 Z2. Okay, then again N12 G01, now it was 26, right? You will make it 24, and the code repeats, N13 G01 Z minus 30. You go, you erase there, again you will come back with the same code, and 14 will be the same code, then 22, then 20. So once you reach 20, okay, I'm not going to do the whole code over here right now. You will be doing it accordingly. Okay, so let's say for example right now we are in N30. So once it reaches 20, let's say for example in line, if you continue like this, it will be N14 will be what, N14 will be, you will be doing the same thing over here, G01 going back to the origin, X32 Z2, right? So once you reach 20, then when you go along the Z, it will no longer be 20, it will be what, it will be 20, it will be not 30. Okay, because we need to go, because 20, then it becomes, as we have seen earlier, the workpiece is what, it's 20, then 16 and so and 14 and then 10, right? So you will be going along 20. Once you will make 14, then you will be going along 10, make the diameter from 14 to 10, and finally, let's say for example the coding you will do so etc. And finally what you will do, you will close the, you need to close what you need to, let's say for example it might be reaching like N37, 36 or anything, it goes on. I'm not going to do it over here, you will be doing it, and I'll be it will be N36 M09, which is stop the coolant. 36 or 37, I don't know what will be the line number according to do what you did. Then N37 what, stop the spindle. M05, first you need to stop the coolant, M05, then you will stop the spindle, M05, and finally N38, end the program, M30. So by this you have completed the process of this operation in the lathe. Okay, so by this I am just giving a brief idea about how you do the lathe operation using the G-coding. So what I want from you is, try the same thing on your own, do the code on a paper, and then I'll also provide a link, okay, where you can download the CNC stimulator. Okay, on that you can do the code yourself. It's very easy, very simple simulator. It's also available on Google Play or Play Store, as well as also on the App Store. I think there is two versions, one is free and one is paid. I think paid is around $10 or something, but the paid one is a really nice one. So it's let's say for example if you want to do more operations and see what is happening, you're most welcome. Or else it's not a necessary thing, you can also try the free one, try on it, but in the free one there are some advertisements, but still it's also nice. I didn't try the paid one, I just gone through the free one, to be frank, and it was quite good one. So what I need from you right now is, I need from you to just do this operation, and I will also provide a submission link. I need you to submit the complete code, and just I will verify it. Okay, and moreover I will also like to say that we have extended the deadline of assignment 3 till this Thursday. Okay, so your midterm will include experiment 4, which is about welding, experiment 5 CNC milling, experiment 6 CNC lathe, and group assignment 3. Okay, group assignment 2 and group assignment 3. So by this, inshallah, hopefully everything goes well. If you have any questions, you are most welcome to ask on Teams anytime you wish. Have a nice day. Thank you.